Hello everyone, my name is Kamil and I'm Head of Engineering Operations at EnergyWeb. And today I have a session for you called Worker Nodes and Smartflow Technology, faster, cheaper and easier. And this session will be slightly different compared to my previous session at the Dive event, because I would like to approach the topic from a little bit different angle than purely technological standpoint, automation standpoint, and this kind of view. So today we're gonna focus on the business side. We're gonna focus on the angle on how you can use the worker nodes and for which use cases they're actually the best to be used for. So you will see that this will be totally, I would say, I hope it will be more eye-opening for you and probably encourage you to explore a little bit more SmartFlow and the use cases that you can speed up on top of the worker nodes. So without further ado, let's get it started. So a couple of words about the agenda. So first, I would like to start up with the EnergyWebX ecosystem and just to provide a proper, let's say, route if you are coming up from the previous dive. I will start up with some small wrap up and tell you again as a refresher what's there inside and what are the components of the EnergyWebX ecosystem. And then we'll move to the business perspective and the enterprise use cases and how do they use the worker nodes and how the worker nodes fit in there along with other components of the EnergyWebX ecosystem. And at the end, I will also provide you a little bit bonus related to our latest releases related to the real money flows. So let's get it on. First, a couple of stuff or couple of words about the EnergyWebX ecosystem. So what you see on the screen is the EnergyWebX ecosystem in terms of all of the components that are inside. On the top left, you have the EnergyWebX, which is a parachain of Polkadot. And within the EnergyWebX, you have the worker node palette. That palette captures most of our custom logic that normally you interact with when you are playing with our ecosystem. Things like operator subscriptions, linkage of the worker to the operator, creation of the solution groups and solutions. This is all captured on top of and inside the worker node palette that we are constantly developing. And just a hint, there will be pretty a lot still going on in 2025. And a lot of new functionalities will be coming there to the worker node palette. In the middle, you see Launchpad, which is our solution as a service platform. And on top of that, we have a SmartFlow as a product under the Launchpad. And with using the SmartFlow, you can do three things, essentially. You can capture and deploy the logic to the IPFS. You can create and manage the lifecycle of the solution groups, and also do the same for the solutions. And solutions, keep in mind, they have the pointers to the logic that is stored in the IPFS. And on the right, you see the worker nodes that are our off-chain runners, lightweight off-chain runners. And I believe since last time, quite a lot changes on this component. So as probably most of you know, we have the worker nodes that are behind the marketplace desktop app, so that are kind of embedded and one piece with the marketplace app. But also we have two more options if you would like to use the worker nodes. One is the managed offering under the Launchpad, and the second one is the open source version of the worker nodes that we did actually pretty recently. So you have all the variety of the ways how to use and how to manage the worker nodes already possible. And worker nodes obviously are responsible for submitting the solution results, and thanks to the marketplace app, you are able to subscribe to the solution groups and manage different operations on chain. And just a recap on the benefits. I would just to emphasize a couple of those. First of all, and I would argue that this is one of the key differentiators if you compare us to our competitors. We really put a lot of effort on the easiness of setup and lowering the barrier for the entry level for your use cases. So really, if you want to quickly start and you go to the launchpad, everything is presented in a very nice UI-driven way with an enhanced UX, and also on the maintaining this enterprise level vibe. So it's pretty confident to use it, and it's in general pretty easy to start up with. We have low costs, so if you had a chance already to play with worker nodes, for example, you know that those are pretty lightweight runners, and they are designed in such a way for a purpose. We want this to be kind of a platform agnostic and be able to set up on your local machine, on your desktop, on your server, inside the Kubernetes, whatever you want. So this is already in place for the worker nodes. And finally, we have ease of integration that I would like to emphasize, because indeed, not only worker nodes, but entire Energy Web X ecosystem is combined and created in such a way that it's really easy to plug and play. And I would say that this is also a huge differentiator if you compare us to anyone else. And to final, let's say, to wrap up this introduction, I would like to start with something that was not really addressed in the past, but I believe it's pretty important. So when you think about the worker nodes, we usually address the technology part, but we haven't spoke that much about the business use cases and for which problems, and how to picture them and how to position them within the context, for example, of your system. And there are two different categories that you can think about. First category, that I call primary, is when the worker nodes acts as an exhaustive replacement for your app or for your entire app functionality. So this is the primary use case, because they are becoming a primary contributor to the system. And in this picture, the custom app fully relies just on the results, and the bulk of the logic is done by the worker nodes. But this is not the main category that so far is of our greater use in most of our projects. And the second category, that I call reactive, is when the worker nodes serve not as a replacement, but rather a complementary factor to the functionalities of the bigger system. They are used in a purpose of utilizing the out-of-the-box features that they offer. So, for example, easy integration with the DLT, blockchain technology, or this trustless execution ensuring, and so on. But they are not replacing the bulk of the functionality. They are just used precisely for the things that matters and where they can shine. And moving forward, I will focus on that second category and how the worker nodes are placed there. So just a couple of features coming from that category, so you get the full picture. First of all, worker nodes runs alongside with the app, and both of those components, so let's say dozens of worker nodes and the app, they both are triggered and execute the logic at the same time. So they are kind of codependent, and whenever the trigger comes, the app itself is executing that piece, but also worker nodes simultaneously are verifying just to be sure that this is executed in the proper manner. Secondly, worker nodes-based run functionalities as a part of a bigger system. So usually they are serving, again, the piece or the functionality that they are intended to be done, or they intended to be and were designed to, but not replacing the entire system. And this way of picturing the worker nodes use cases as this category is a perfect balance between the speed and security, because your app is not harmed by any, let's say, hiccups that can be there between the large amount of worker nodes and their possibility to reach the consensus, but yet this consensus will be there, and you will have a security coming from the worker node integration, and that integration alongside towards the Energy Web X and DLT technology. And now, as we are moving closer, we know this category, and let's now talk about a little bit about the problems and the types of use that the worker nodes are perfectly designed for. And there are 4 categories or 4 types of use that we can distinguish. First one is trustless execution in the decentralized manner. Second one is public verifiability, for example, for auditing purposes. Third one, participants incentivization. And fourth one, which is pretty common in terms of the enterprise blockchain use case, is the use of the blockchain in a private manner in the first place, which is also a good use case to, or use type to be addressed for the worker nodes. And now let's deep dive into each one of this, because I would like to really to capture the idea behind each of these use types. First one, the trustless execution. You can think about this in a case when you have a multi-party system where those parties are coming from totally different companies, for example. So there is inherently a lack of full trust between each other, and therefore they cannot rely on a single server run by a single party for the results of whatever logic they are willing to execute to be certainly true. That's why, and that's where the worker nodes and the energy ecosystem perfectly fits, because you can distribute the logic among all of those participants, allow them to reach consensus, and therefore contribute meaningfully to the app. So that's the first one. Next one, we have the verifiability. This comes from the set of requirements related to the tamper-proofness of the results of your execution. Maybe, for example, some of the requirements are for your system that your app results or the results that you are claimed to be that were executed can be audited in the future. So using worker nodes and EnergyWebX ecosystem connection, you can easily achieve that, because you can basically easily connect the results that are sent from the worker nodes executing the business logic that later can be validated by the external auditor. Third one, participants incentivization. This is a typical use case that if you are contributing in some solution group, you are experiencing on your daily manner. Basically, if you have a system where you want to encourage, for example, to achieve a high degree of decentralization, you want to encourage public participants from random locations all around the world, let's say, that are fulfilling or that are aligned with your government's needs, then you need to be able to easily provide them some kind of incentives, like monetary rewards. So again, EnergyWebX ecosystem and the worker nodes are coming with this type of problem resolution. And the last one, as I already mentioned, still, which is might be for some of you surprising, but still, as we are on this verge of talking with lots of the enterprise, still often those players are considering private blockchains for the variety of reasons. Reasons related to the non-disclosing raw data on the blockchain, of reasons related to the permissionless or permissioned need of structure for the contributors, or being only in certain locations or within, for example, a secure DMZ network, private network. And all of those requirements are again easily addressable within the EnergyWebX ecosystem components and the working nodes. So, for example, never a raw data enters the blockchain, is always hashed. We have a pretty advanced and flexible governance that allows you to set up the rules of participation and, for example, maybe just whitelist the operators that you know and that you want to participate. Or lastly, worker nodes are perfectly capable of working within the private networks. That means you can really set up a secure environment isolated from the outside world, with your workers being a perfect fit there. And that's, I would say, wrapping up the introduction of the categories that we are going to address and the types of the use cases that are there for the blockchain worker nodes, for the EnergyWebX ecosystem. And now we'll move to actual enterprise business use cases that from the from the moment of creating the Energy of X ecosystem, we have been addressing using our pieces of technology. And I will not focus on that much on the entirety of the use case and deep diving into it, but rather the main focus will be going to the worker nodes and how they are used within that context of that project. Because lots of this project were already being discussed in the past, and therefore worker nodes are the key, or the way they are used is the key actually to understand the power of the Energy of X ecosystem and that technology. So first business use case is SAFC, Sustainable Aviation Fuel Certificates. There were already multiple presentations about that, so I will not deep dive into the use case. But from the technology standpoint, we have a platform where various of operations related to the SAFC certificates can be done. And those operations are issuance, transfer, retirement of those sustainable aviation fuel certificates. And as it goes for the worker nodes into the picture, any of those operations are not only confirmed by the central server, but worker nodes also do conduct the operation of the verification of those operations. So we ensure that this is not only, let's say, again, validated by a single party, but also by the dozens of the worker nodes that contribute to this ecosystem. Next one, Green Plus for EV. So some of you might already played with the beta version of the Auto Green Charge that we used to have, or maybe you are actively participating in the Green Plus for EV pool. Long story short, here the use case is that we have a platform, in this case app, that is on the one hand side connecting local energy attribute certificates providers, certificates coming from the green energy, with the owners of the electric vehicles that want to greenify their charging sessions. And they can greenify it by matching a fractionalized certificates, this EAC certificates. And again, a platform is ensuring that there is a proper issuance, transfer, and retirement of the certificates. And again, speaking about the worker nodes in this context, worker nodes are providing this layer that not only we rely on the single server or single entity, ensuring that those certificate-based operations are done properly, but all of those worker nodes are also verifying the issuance, retirement, and transfer of those certificates. Next one, Green Plus for BTC, that is already live on production and with further development in the pipeline. And here, as stated on the slide, the main use case of the platform is to empower Bitcoin miners with tools and showcase sustainable energy use with a goal to make sustainable Bitcoin mining ambiguous and accelerate the clean energy transition. And here, this is a first slight change in how we are using the worker nodes here, because here we are not operating on the certificates, but rather worker nodes here in the picture are the verifiers of the verifiable credentials that those Bitcoin miners get based on the, let's say, business process defined outside of the blockchain world. That and those credentials are verifying that the Bitcoin miners are reaching their sustainable goals or they are still green. And those worker nodes are verifying in a scheduled, pretty frequent manner whether those credentials were not revoked, and those Bitcoin miners are still the ones that can participate in the system. So that's, as you see, it's slightly different use case, but here again, we are removing the reliance on a single party for this transparency use case, and we are ensuring that Bitcoin miners, should their stop being green, is quickly spotted and confirmed by multiple parties. Next one, that's 24/7 matching, electricity matching, that was done as a POC. Basically, the goal of this POC was to create a platform where it was possible to match supply and demand side, supply coming from the green electricity producers and demand of people that are willing to compensate their energy use only with the green energy. And here it's also interesting pivot, because worker nodes in this picture were used to run the matching algorithm between the offers and the suppliers of the green energy electricity. So again, not only we were relying on the single party or single server, but all of those worker nodes were able to prove run the algorithm. So we reached the consensus that this is actually the valid claim or the valid match. Next one, Omega X. This is first project that we're going to discuss, which is coming from European Commission research bucket. It's currently in the development. And here the use case is very similar to the auto green charge that was in the beta, but it adds this flavor of being a cross-country. So long story short, we are allowing the users we are going to allow the users of the platform to not only use, let's say, the rules, as in the case of the outer green charge, locally, but also inherit these rules when we are, for example, in a different country. And again, worker nodes here in the picture are verifying the issuance, transfer, or retirement of the certificates. And keep in mind that here we are also adding on top the digital spine client, or the intention is to add the digital spine client to ensure this OCN cross-country. Next one, in excess. I have to say that I really like this use case personally, as it's easily relatable. So the use case is that we have 4 pilot projects in the four different countries where we are taking a property. That property, we are establishing a baseline for the energy consumption, and the investor comes and renovates this property with the goal to decrease that energy consumption. And later on, we have the MRV algorithm, which stands for monitoring, reporting, and verification. And worker nodes in this picture are running this MRV algorithm, and being connected to the data coming from the smart meter, they are able to validate the decrease of the energy consumption versus the established baseline that was there in the very beginning. And thanks to that, based on the calculation of that gap, we are incentivizing or routing back the money that investor put into for the initial renovation. So I believe it's pretty interesting. And again, putting this algorithm to be run by the multiple workers is ensuring the trust of the entire system. Next one, from the umbrella of European projects, we have Intelligent and U2 Demo. The goal here is to create a P2P platform for tradable energy assets trading on bids and offer matching. And again, here the worker nodes are serving as the runners of the bids are intended to serve as the runners for bids and offer matching algorithm. So whenever the new offer comes, they will be able to execute that algorithm, fetch bids and offers data, and match it properly. So again, as you see, the flavor of decentralizing the algorithm, so making sure that the core of the system is done in really confirmed manner. The next one, the last one from the European Commission research project umbrella, ECS for GRES, which is also in development. And this use case is very similar again to the SAFSI, because the goal is the platform where energy origin certificate, but in this case coming specifically from the green hydrogen, will able to be to be issued, transferred, and retired. So here in the picture, the use case of worker node is similar as there. They will be verifying those certificates operations. And last one that I wanted to mention is OEP and ZEL, which is a use case that we did as a POC. And this use case was, I believe, multiple times discussed in the context of our Edge project that is done in Australia with AMO. So I will not deep dive into it, but the worker nodes here were executing the operations related to a OEP or their request in the decentralized manner to ensure that it's done confidently. And from the standpoint of the use cases, that's it. And now let's just move to this final piece that I wanted to discuss, which is this bonus part, I would say. Because you heard about all of those themes that I talked about, and depending where are you coming from, it might be less and more interest of yours. So let's say I assume that if your goal was to understand more use cases, or coming from the technology standpoint, that was for sure very interesting for you. But if your bias is more towards the rewards and contributing to the solution groups, this is something that probably you would like to hear the most. So as probably some of you heard, recently we have released the EWT-based payments for the Launchpad. And also what you also seen in this session is that most of the project that Energy Web is building alongside with those various use cases have in their diagrams and their architecture various of the components from our ecosystem, whether those are RPCs of the Energy WebX or Energy Web Chain, whether this is Smartflow to be used for creation of the groups, solutions, or the capturing of the business logic, or the worker nodes in itself as a runners to be able to execute that logic. All of those elements are easily deployable from the Launchpad. And in case of certain projects, that's how it is used. And you can think about this, that if there is a case that someone uses EWT for purchases of any of those tooling from the Launchpad, there is a certain piece from that payment that will be rerouted towards going back to the solution group rewards. So speaking of this angle, you can think about this, that this is our first step of introducing a slight shift in the economical model here, because with subscription model, you have not a single payment, but a recurring model. And this effect will obviously compound over time. And therefore, the more there is the subscriptions, the more piece or the more portion of this EWT will be rerouted back to the solution groups. So therefore, you can think that even though that your bias is purely rewards based, there is an incentive actually to deep dive into the technology and into those projects and understanding this, because maybe even casually talking with someone, you may encourage him to utilize this, and therefore at the end the rewards based on the purchases could be increased. So just something to think about. Yeah, and that's it. I hope you find this session interesting, and please enjoy the other dive sessions. And thank you so much for listening. Thank you.